So the topic for this particular video will be open close principle or OCP. Now this is the O in solid principle. So as of now, we'll be studying about OCP, and as we move into the playlist, we'll be understanding the three other principles as well. What is the definition of OCP? Let's understand it. Software entities like classes, modules, and functions should be open for extension but closed for modification. What that means is you should be able to add new behavior to a class or a module. You can add a new behavior, but that is only through extension, and you shouldn't be changing the existing code. That is something you should avoid. Let's understand. Imagine you have a class Z and that has some functionality, and this class Z is being used by someone at a place A, someone at a place B, someone at a place C, and so on. Could be microservices, could be different classes, could be different services, could be literally anything, and they're using the class Z's functionality. Now suddenly you come up and say that, okay, I'm going to change a bit, I'm going to do some changes, thereby I'll be modifying the function. Now what will happen is, because you're modifying the function, someone at A who's using it will be affected, the B will be affected, the C will be affected, and everyone else who's using it will be affected. So is that preferable? No. If you're doing a change, you'll have to inform everyone who's using it. That can be very hectic, isn't it? Because you might be new to the code base and you might not be aware who is using it. There might be, hundreds and hundreds of microservices, hundreds and hundreds of services using this particular functionality, and you will end up breaking it. That is why it is stated that do not modify any existing production code. If you want to do something, do it using extension. I'll give you an example, you'll understand, but as of now, understand the bookish definition. It's pretty much clear, right? Perfect. Let's go up. So I can say that I understand the definition on a very high level, that I shouldn't be tampering or I shouldn't be modifying the existing code. I should always use extension. Okay. Next one. Can you give us a real life analogy? I can. Let's take this adapter. Now, this is something, this plug, this works properly in India. But if I go to Europe or to a US, this will not work because the plug points over there are different. And if I try to plug it, it will not get inserted. That is why what we do is we buy travel adapters. And what we do is we attach it to this one. And that adapter is something that will be fitting in to plug points in US or maybe Europe. What am I doing? I'm not tampering with this. What I'm doing is I'm extending this with an extension, and the extension is a travel adapter. Am I modifying the behavior of this? No. What I'm doing is I'm just extending the behavior. I'm adding a new behavior, but through extension. So this adapter is a classical example of open close principle. If required, I'll add a layer on it. I'll just extend it, but I'll not be touching this. Am I breaking this? No. Got it? So the real life analogy is clear to you, isn't it? Okay. Time to understand open close principle with a real world example. Tax calculation in an invoicing system. Imagine you're building a system where currently you are located in India, and you'll have to always generate invoices, and for that you'll have to add taxes as well. So initially the team, you're just in India. So how will you code it? Because I'm in India and I don't have to care about something like a EU or US taxes, I'll be straightforward. Hey, okay, I need to have a tax calculator. So class tax calculator, and I'll do public double amount after tax, and I'll take the amount, double amount, and all I'll do is I'll return amount plus 0.18 into amount. I'll add 18% tax to it and I'll return. Now this will work fine. Imagine this being used by multiple services, something like a class invoice service. And the invoice service is going to use it, public void function, a calculate, something, whatever you want to call it. And inside that, what you'll do is you'll just do a tax calculator equal to new tax calculator. And in order to get your amount, all you need to do is tax calculator, amount after tax, and pass on the amount. Very simple logic. The logic would definitely be tougher than this, and the tax will be calculated. And this will work absolutely fine, right? And this tax calculator might be used in a lot of places. Somewhere like a payment gateway, it might be used somewhere like a subscription service, somewhere like a billing service, and this could be used at multiple services, multiple microservices as well, right? Another question is, tomorrow when you are expanding it to somewhere like a US, somewhere like a Europe, how will you deal with it? A classic way will be to just apply our DS algo logic, and it'll be like, okay, I'll take a string region. I'll just take a string region, and depending on the region, if the region is, let's say, India, I'm gonna return something like this, whatever I'm returning. Or else if the region is US, I'm going to again return something else. Maybe I can just copy paste this. Maybe I can say US has 10% taxes. I'm not sure how much they have. Otherwise, in any other case, I'll just return the amount, stating that we're not going to add any taxes. So this is just for India and US. Do you see a problem? You do see, right? Now, because I modified an existing class, I did some modification. I changed its code. What happened? This invoice service, which was using it, is now throwing an error. That might be an issue. So you'll have to fix this. And you'll also have to tell all of your services that are using it, hey, fix it, hey, fix it. And that might take time. That is why this is something which is not preferred. And now you might be asking, hey, Striver, then how do we do this? In this scenario, what you will do is, because the invoice service people will come across to you and say, hey, we need a change in tax calculation because now we are getting into US, getting into Europe. So please allow us to do that. So now what you will do is, instead of doing this, you will say, I'll go through an interface, which is a tax calculator. And I'll say public double. Maybe I can just have a double amount after tax. And I'll take a double amount. Perfect. So what I've done is I have an interface now, right? I have an interface. And now I'll have class Indian tax, which is implementing this tax calculator. And over here, I can say public double amount after tax, and I can take double amount, and I can return amount plus 0.18 into amount. I hope my calculations are correct, but yeah, you get it, right? Now over here in the invoice service, I can literally convert this into an Indian tax, and this will be fixed. Any other service which we're using it, it's fine. Tomorrow, if I have to add a US tax, all I need to do is I need to copy paste this. I'll just change it to US. That's gonna work. I did an extension of the logic. I'm not modifying the code. I'm just doing an extension. And now in order to use it somewhere, I'll just change it, and that works. And now this particular object, do I need an Indian one? Do I need an US one? Do I need a EU tax? That can be decided on the basis of IP address or on the basis of where the customer is from. And I can do it on the service end instead of changing the main core logic. Again, this is a very simplified design. You can add composition to it as well, which we will be doing as we understand design patterns. We can use a factory pattern as well in order to determine whether to use India's taxes, US taxes, or EU taxes. We can do a factory pattern over there as well, which I'll be teaching you later in the playlist. But you need to understand what I'm trying to give you as of now. Extension. We can add more code, but we will not be modifying existing code. That is what open close principle is all about. I hope you get that right. Perfect. So since this is clear, what I can do is I can go back and say, now we know real world example. Next question, hey, when should we apply OCP? Always or not? Again, is something which which you have to take a call depending on the use case, but I can give you some hints. First of all, whenever your business rules are likely to change or expand. For an example, with TUF Plus, as of now, we are using a payment gateway. Let's say PayPal. Tomorrow, we decide that we have to offboard from PayPal. Now, I don't want to change all the code. I just want that I'll change very limited line of code and it starts working. And maybe I want to preserve the PayPal code. So I can just have the PayPal class somewhere and I can use some new payment gateway class and I can just replace it. So this is how you'll have to think. If your business in the future will require a change or will require an expansion, if you can think about it, then it's better that you follow the OCP, which is the open close principle. Perfect. When you're building a plugin system, now what does a plugin system means? So I'll give you a classic example. We have AWS, which is giving you, web services. At the same time, we have GCP. Let's assume our code base as of now is completely using AWS. We are on AWS and we're using all the endpoints of AWS. Tomorrow, if I decide, hey, it's costing us too much, or maybe GCP is giving us some free credits, which is going to take us for the next 2 years. We'll decide that we're going to migrate from AWS to GCP. Now, this is where I have to think that can I do minimal changes? And that will only be possible if the GCP is designed in such a way that we only change certain things in our code base and we can start on GCP straight away. But if I have to change the entire logic, entire code, it becomes extremely difficult. So if you're building a plugin system, you will have to take care that most of your endpoints, most of your things have to be following OCP, which is open close principle, similar to gateways as well. If you'll see, most of the gateways have pretty much similar endpoints, and even if they're using more and more, let's say, payment methods like UPI, credit card, crypto, the design is following the OCP principle because they're just extending the methods that they're allowing you to use. Got it? One more example I can say is the notification system. Previously, we used to have just email notifications. After that, we had text notifications. Now we have WhatsApp notifications as well. Imagine if I'm modifying the original code. It's going to be messy. So it's important that you design it in such a way that we just add WhatsApp class and it starts working seamlessly. That is where open close principle will be worked around. Perfect. When your code base is becoming a God class, imagine you just write everything under one service or something around that. That's when it's better that you move out and you split it into, single kind of thing. You follow the single responsibility principle at the same time, OCP as well. That is when you should think about OCP. Again, is it something you should definitely follow? Not really. Depending on the timelines, depending on your use cases, you'll have to take a call, but it's a good one to follow. Perfect. Misconceptions about OCP. Let's get about that. So there's a lot of misconception. A lot of times it is like, hey, it means never touching the old code because it's going to break services. We may touch it. Yes, we may touch it. Tomorrow, if we are implementing a feature which is going to replace the older one, maybe we'll have to do some changes in the older code in order to get the new thing in. So it's not touching old code. If it's needed, you will touch the old code, and to everyone who's using it, you're going to reach out to them and say that, hey, we are doing this, please update your code. Hey, we are doing this, please update your code. Or you'll have to find out a solution where you gradually deploy it. So it's not touching old code. No, you can replace old code to support OCP. If you have realized that there's an issue, maybe you can implement OCP in the old code as well, or you can change the old code as well. There's no hard and fast rule that you're not allowed to modify the old code. There's no hard and fast rule. Keep that in mind. Okay? OCP leads to more classes, so it's an overkill. A lot of times people will say you're unnecessarily creating a lot of classes and all of the other things. Initially, it does make sense whenever the code base is very, very limited. But as the code base grows, large, that's when you realize, oh shit, I should have followed the design principles. So extra classes are fine if they improve maintainability, and you'll only understand maintainability once your code base grows humongous. So if you're working in an MNC like Amazon, Google, Facebook, Netflix, Walmart, Microsoft, or any other bigger company, you'll understand the use cases of this. But if you're working in a startup where the primary goal is to ship fast, that's when people compromise on designs, which is okay, because for them revenue matters, for them shipping matters. So yeah, it's a subjective thing. Next one, it makes code harder to read. I just gave you a very simple example, but if I include factory pattern, if I include composition, it might happen, if you're not aware of all the design patterns, it might just get difficult for you to read through the code as well. And is that a misconception? That is kind of true, but again, that means you're not aware of design patterns. So not if done right. If you are doing it right and if you're aware of everything, I think you gain a lot of flexibility, because if you're aware of design patterns, you can always extend on it. Got it? And that was about the misconceptions about OCP. So that is about the ON solid principles. I hope you've understood it. And yeah, this will be it for this one. In the next 3 lectures, we'll be discussing the L, I, and D. With this, let's close this one. Let's meet in the next one. Thank you so much for watching.